What's going on, everybody? It's Charles. In this video, I'm going to show you how to do some engine health evaluation before making serious modifications to your car. I want to do an evaluation of the overall health of the engine. Nothing worse than spending a bunch of time and money modifying a car, all to find out you really have some serious engine issues. So today we're going to walk through a handful of things that it's really a good idea to do before throwing money and parts at a car, all chasing horsepower. Now, there is a number of different ways you can evaluate overall engine health and overall vehicle health. These are just a few that I like to use. It's also worth pointing out that there is different ways to do each one of these tests. For example, the compression test that we're gonna do, we're gonna use a mechanical gauge for. If you have the right equipment, doing this with a scope and checking relative compression on the engine or using a pulse sensor rather than a mechanical gauge are all great ways to do these tests. First up, we're gonna start our evaluation with a simple visual inspection. We're looking for significant damage here, like a hole in the block or significant oil or coolant leaks. Any of these problems can be amplified when we make modifications to the car. In a perfect world, we would wanna drive the car and listen for any weird or abnormal noises. In the case of this black R32, it's not super drivable, so we're gonna skip that step here. Of course, you wanna document anything that you find, even if you think it's minor. It's good to have a record of it before making the modification. We're also using this step to evaluate if we even need further testing. If you get in and find a hole in the engine block, well, no more testing really needed to be done. Now, for pretty much the rest of our testing, we need to have the vehicle up to operating temperature. And in order to do that, we're gonna get it out of the shop, so we're working in a well-ventilated area. Next up, if you have a car that's 96 and newer, it's a really good idea to go ahead and scan the car and see if there's any stored faults. It looks like in the case of our R32, we have a handful of faults that all read as intermittent. You have a choice to make. You can go in and analyze some of the stored data in the ECM, like fuel trims and things like that. I'm gonna go ahead and clear these faults out and start fresh. Next, what I wanna do is check the amount of chain wear or chain stretch. As we know, chains don't really stretch, they actually wear. Luckily on this car, we can go in with the scan tool and look at our intake cam adjustment and our exhaust cam adjustment and calculate how much quote-unquote stretch the chain really does have. First thing we're gonna need to do is let the vehicle warm up to operating temperature. I think the minimum temperature is about 60 degrees Celsius. Once the vehicle warms up, what we're gonna do is we're gonna go to measure value blocks 208 and 209 and evaluate field 3. This will show us our stabilization at idle and give us an idea of how much the chain has stretched. Now we're showing a -2 and a +2. That's really good. That's basically zero stretch, kind of like a new chain. I'm pretty sure this car has had chains at some point. So based on these numbers, I think we're good on our chain. The spec on these readings is anywhere from -8 to +8. So anywhere in that range is technically okay. However, if I'm at 6, I'm a little uncomfortable. If I'm at 7, it's time to do chains. And if you're at 8, you're probably getting some noise from the engine as well. At the -8 or +8 number, you may or may not get a fault code. So this is something in the VR6 world, if you have, it's a good idea to do this quick check and see where you're at. My blue R32 I know is on the original chains. It's got 156,000 miles on it. Let's hop in and see what it reads just so we can compare to what the black car reads. We'll go into measured value block 208 and 209. And as we get into 208 and 209, we see that we actually have a -5 degrees of crank rotation and a -7 degrees of crank rotation. So at 156, there's quite a bit more adjustment happening on the blue car than on the black car. And I gotta tell you, I'm probably going to move timing chains up a little bit higher on the list than I had previously wanted to. Definitely don't want to have a catastrophic chain failure, but all things considered, at 156,000 miles, that's not horrible. Next up, we wanna get rid of any engine covers that are going to be in our way for our next series of testing. Now, if we're adding horsepower, odds are we're gonna put some kind of different air filter or intake on it, but it's worth just taking a quick look at the engine air filter to see what kind of condition it's in. This one already has a performance air filter that looks super duper dirty. So look at that. Ugh. So cleaning this air filter will be on our to-do list. Let's talk about some of the tools that we're going to be using. We have our compression tester, we have a vacuum and pressure gauge, and we have a cylinder leak tester. We aren't necessarily going to use the cylinder leak tester unless we find a problem with one of these two gauges. Because it's easier, we're going to start with our vacuum gauge. You can actually learn a lot about the health of the engine by simply using what's actually a pretty inexpensive tool. I like starting with the vacuum gauge because it really requires the least amount of actual work to use, and I'm a fan of that. So let's go ahead and get our gauge connected to our hose. Then what we're gonna do is we're gonna find an open vacuum port on the engine. On this car, it's not that challenging. There's a couple of places we can tee into. On more modern cars like, say, the Golf R, it gets kind of tricky to find a good vacuum source. Now, when looking for this vacuum line, you want to make sure that you're not hooking it up to the evap purge system. That can really skew your vacuum reading. And you don't want to hook it up to a brake booster that uses a mechanical vacuum pump, because then you're not actually measuring the health of the engine, you're simply measuring the health of the vacuum pump. We want to find a good vacuum source and tee into the line, making sure that we don't leave something unplugged or leave an open vacuum connection. Remember that an engine is simply an air pump. Air gets sucked in, air gets pushed out. And vacuum readings are dependent on the altitude that you're at. I'm at about 300 feet above sea level. The higher your altitude, the lower your vacuum readings are gonna be. And of course, different engines can have different normal vacuum readings, but typically a reading of 18 to 22 inches of mercury is pretty standard. The first vacuum test that we're going to do is called a cranking vacuum test. Here we're going to observe the reading on the vacuum gauge as well as the tach and compare our vacuum reading to our RPM. First thing we need to do is we need to prevent the vehicle from starting. In the case of the R32, this is super easy because if we pull fuse 29 in the fuse panel inside the car, this not only disables our fuel injectors, but it also disables our coil packs. You're of course going to want to check on your car to make sure that you're disabling the car from starting. So what we're going to do is we're going to crank the car for about 10 to 15 seconds, and we're going to look at our vacuum reading as well as our tach. And what we're really looking for is just a nice consistent number, usually around 5 inches of vacuum. It looks like in our case that's a little bit lower, but I'm not too worried about it. If you were to see that vacuum gauge go up and then drop or bounce up and down from, say, 4 to 0, that would indicate that we may have a problem and then we're getting vacuum leaking past the valves or the rings or the head gaskets, or you have a cylinder or two that's not pumping enough. Once you've done this test, be sure to document your readings. Write this stuff down. We don't want to get halfway through the test and forget where we're at. This is actually a mistake I see professional technicians make all the time, is not doing a good job of writing down their reading. So based on that reading, it looked like both our RPM and our vacuum reading was a little bit low. And on that second cranking, if you listen really closely, you can actually hear that I think the battery is just a little bit weak. It's very important that we have a good battery in the vehicle. Really, the best thing you can do is put a charger on it, make sure that you have a consistent good battery voltage. This not only will make sure that our testing is consistent, but that we don't run into an issue with our test results due to the engine not cranking over fast enough. Next, we're going to be doing an idle vacuum test, and this is really the one that's like the traditional way that people use their vacuum gauge. Let's go ahead and put our fuse back in and start the car up. We're already up to temp, so we don't need to worry about that part. As you can see, when we first start up the car, we're right at that 20 or so inches of mercury reading on our vacuum gauge. That's perfect. That's exactly what we want. When we're looking at this, we're looking at the overall engine's ability to breathe. Let's do a couple of things and see what happens to our vacuum readings. First thing I'm going to do is I'm going to disconnect this vacuum line at the back of our engine. As you can see, when I take that vacuum line off, our vacuum reading drops. Next, what we want to do is crack the throttle and rev our engine up and see what our vacuum gauge does. It should go almost all the way to 0 and then go maybe even a little bit past our idle reading and then settle back at right where our idle reading was. This means our throttle is both opening and closing properly, all good things. Really, in a perfect world, you would also want to do this while you're actually driving the car and having the engine under load. That would be a far better and more accurate way to do it. Given the shape of our car, though, that's not something I'm prepared to do. We can also use this vacuum gauge and these readings to do what's called a power balance test. Let's say our vacuum gauge was reading maybe a little bit low, but it was fluttering a little bit. Maybe it was moving between 16 and 18 inches of mercury. That could be because we have one cylinder not really doing its job as well as the other 5 cylinders. We can go through and disable one cylinder at a time and see which cylinder has no impact on our vacuum reading. There's a really good example of how having 1, 2, 3 cylinders not doing their job properly can show on our gauge. We can also use this to determine if we have a restricted airway or a restricted exhaust. I tried to restrict the exhaust, but unfortunately just found out that the car has an exhaust leak, so not really much help there. But But as you can see here, I'm gonna put my hand over the intake and start to block the airflow into the engine. That too is shown on our vacuum gauge and shows that we have a problem with air getting pulled in. So based on these readings that we're finding here with our vacuum gauge, I would say our engine's probably in pretty good health. And after you've found your vacuum port and done this once or twice, you can do this test in just a matter of a few minutes. Let's move on to our next step, which is going to be an actual compression test of each individual cylinder. First up, ignition coils come out, spark plugs come out, and we want to disable the engine from starting, so we're going to pull that same fuse 29. Also, go ahead and get that battery charger, battery maintainer on your battery. Make sure you got plenty of juice because we're going to be cranking this thing quite a bit. Let's go ahead and get our gauge set up. This is just a basic compression tester kit. We have our gauge and we have our hoses, and we're actually going to need one of these adapters for this engine because the thread pitch is a little bit different. This is pretty simple. It just screws right on here. You can snug it down by hand. Also a quick tip, if you have to use one of these adapters to do your compression test, throw a couple of twists of tape around it to make sure that the adapter doesn't come off and get stuck down in the spark plug well. And then the way I like to do it is I'll take the loose end of the hose without the gauge on it, start in our first cylinder, get that snug down. Then we'll take our gauge, get our kit out of the way. We'll go ahead and plug our gauge in like that. Also another vital thing, just like our vacuum test, got to make sure we document. We're going to go to each cylinder and measure the compression. This really works well if you have someone that's able to help you out so you can monitor the gauge. Go ahead and crank the engine as if you were trying to start it until your gauge really stops moving. There'll be a little bit of flutter at the top end, but once it's kind of at its top point, you can stop cranking. We're gonna take that number, write it down, bleed the pressure out of your compression gauge, and do that for each cylinder. There's one other thing that a lot of people do, and that's actually push the throttle pedal all the way down to open up the throttle body and allow more air in. This becomes a bit tricky on a lot of modern cars with electronic throttle because the throttle may not actually even open even with the throttle pressed all the way down. In my experience, I've actually found that there is enough airflow through the engine even with the throttle body mostly closed in order to get an accurate compression reading. This may not be the case on all vehicles, but that's just been my experience. So it may be worth doing it both ways and seeing if the throttle even opens or if there's any impact on your compression reading. Once you have compression readings for all the cylinders of the engine, it's time to compare our readings. Compression on a new VR6 engine runs anywhere from 10 to 13 bar, which is 145 roughly, to roughly 190 PSI. The max wear limit is 7.5 bar or about 110 PSI. The big thing here that we usually find though is the difference between cylinders. And you don't want to see a difference between any of the cylinders of more than 3 bar or roughly 44 PSI. So even if they're a touch low, as long as they're pretty consistent, you might be okay. Now there's obviously a threshold where it's too low and you wouldn't want to add more horsepower to the car. Say if we were under 10 bar, 145 roughly PSI, we might want to consider doing some engine repair or refresh before throwing boost at it. Now, if you run into something kind of strange and maybe your gauge reading's off, it's reading too high, it's reading too low, something just doesn't seem right, don't get hung up on that one cylinder. Write down what your results are and move on to the next one. It could just be that the hose wasn't all the way tight or something was just off on that one cylinder. And then when you're done, go back to that one cylinder that was kind of wonky and test it again. You may find that something just wasn't fully secure, or you may have actually identified a cylinder that's a problem. And I always like to run those tests twice on ones that are suspect just to make sure that I'm getting a consistent result. If you're finding that compression is a little bit low, maybe worth squirting a little bit of engine oil down into the cylinder and doing what's called a wet compression test. Doing this, you may see those compression numbers climb up to right where they're supposed to be. All right, so we did our engine vacuum test and we measured our overall engine's ability to breathe. We've also done our compression test and measured each individual cylinder's ability to build compression. We're gonna do one more test before we give the go stamp on our engine. Now, a lot of times you might not actually do this test if everything up to this point has checked good. However, I think this is a super valuable test to know how to do and understand really why you're doing it. So very similar to how we did the cranking compression test, we're gonna use our same gauge, our same hose, and we're gonna do this test while the vehicle is running. This is going to allow us to look at each individual cylinder's ability to pull air in and push air out. That vacuum test we did at the beginning is an awesome and super important test, but that is the whole engine. When we're doing the running compression test, this is the one that's going to allow us to isolate a cylinder that may have an issue. A standard cranking compression test or a cylinder leak down test will point out a lot of issues. However, there are certain failures that may not show up in either one of those tests. That GTI I had many years ago where the rocker fell off and wasn't opening one of the valves wouldn't show on a cranking compression test or on a cylinder leak down test, but it would have shown on a running compression test. For our running compression test, we do need to get the engine back together, spark plugs in, coil packs in and plugged in, and we need to put our fuse back in for our fuel pump. If it's possible, you want to disable the fuel injector for the cylinder that you're testing. However, on this car, it's super hard to get to each individual connector for the fuel injectors, so we're going to let them go ahead and go. Inside of your compression tester, there's going to be a Schrader valve. This allows the gauge to seal when we're doing a cranking compression test. Some people like to take that out to do this test. I like to leave it in because I think it's a little bit easier to do the test. So once we have all the spark plugs and everything back together, we're going to thread our compression tester in the exact same way we were doing when we did our cranking compression test. Of course, make sure everything else in the car is good, and go ahead and start the car and let it idle. A fair warning though, the car's gonna misfire and not run super well because you're not firing one cylinder, but that's okay, we're still gonna be able to get our reading. So we're gonna start our engine and let it idle and get an initial idle reading. Most tests recommend that this idle reading is actually taken at a high idle of about 1200 RPM. In my testing, I found that the reading was pretty much the same at standard idle, about 800 RPM, and at 1200 RPM. So you might have to play around with the engine you're working on to see what works. Now, if you did leave that Schrader valve in, you're gonna wanna bleed the pressure off of your gauge every few seconds just to reset the reading. For our test at idle, we're looking for a reading of about 50 to maybe 80 PSI. Oftentimes you're targeting about half of what your cranking compression was. So grab that reading and make sure you document it. Next, what we're gonna do on that same cylinder is we're going to do a throttle snap reading. This is a little bit tricky on cars with electronic throttle bodies because we don't really wanna rev the engine. If this car had a cable throttle body, we would take our hand on the throttle body itself and snap the throttle from 1200 all the way open and right away all the way back to idle and see what our max number is. We want to make sure to do this as fast as possible. We're looking for the engine to take a really big deep breath here. For that throttle snap compression reading, we're looking for that to be about 80 or so % of our cranking compression. In the case of the R32, I want to do every cylinder and see where they're all at. If you were working on a car that had an identified cylinder issue, I would probably start with that cylinder and then take a couple of readings on other cylinders. Numbers may vary depending on the engine type. We're really looking for things to be consistent here. How do we know if we have a problem? Well, looking at the numbers that I got, everything looks pretty good. Let's say our static compression was good and our idle compression was good, but our snap throttle compression reading was low. We would be looking for problems on the air intake side, maybe something like a worn cam lobe. If everything looks good but our snap throttle reading is high, that means air's not leaving the cylinder like it should, so we'd be looking for similar things on the exhaust side. This might even show, say, a clogged catalytic converter. If we find that our idle reading is low, that cylinder is not holding compression effectively. Now, those readings that I mentioned targeting for idle running compression and that snap throttle running compression are kind of baseline standards. If you do find that you have a problem with an engine, you want to really do the entire engine because we're looking for things to be consistent. For example, my running compression numbers at idle were all right about 55 to 60. That means that everybody's consistent. If one was way high or one was way low, we would isolate that one cylinder as being problematic. It is important though to really use your brain in evaluating these numbers. If we did that snap throttle reading and found that all of our numbers were low, we might be looking at something in the exhaust side impacting the entire engine. A clogged catalytic converter is a perfect example of that. Or if you have a true V-style engine with a bank 1 and bank 2, and all of your numbers on bank 1 were low, but all of them on bank 2 are right, then we would be focusing on maybe the bank 1 exhaust muffler catalytic converter. This is why documenting the information that you extract while you're doing the test becomes so important. We don't want to jump to a conclusion mid-test without evaluating everything and looking at the entire scope of the engine. Now, I don't know about you guys, but I am fascinated by this kind of stuff. I mean, it would have been awesome if we found a problem that we could then actually correlate, hey, this bent valve when we pull the head apart shows on this reading here that we did. Fortunately, we didn't find any of those issues, but kind of unfortunately, we didn't find any of those issues. Either way, overall, I'm pretty happy with the health of the engine. Would I throw 30 PSI of boost on it? Probably not without a refresh. However, I would actually be okay continuing to drive the car or even some light modifications without any internal engine work. And as I say all this and spent all this time making this video, it may have seemed like a bit of a waste of time if we're going to be pulling the entire engine apart anyway. However, there is a lot of value in learning how to do these tests, learning what results you're looking for versus what you get, and learning how to look at these numbers and evaluate the health of the engine in tests that you can do all together in 30 minutes or so, depending on how hard it is to get to a lot of this stuff. But either way, time to wrap it up. I hope you guys are enjoying this R32 project. I can't wait to get this engine torn down, put back together, and a whole lot of fun, go fast goodies on it. With that, I'm out. Have an awesome day, and I'll talk to you guys again next time.